What we have today is a smart mechanical reinforced concrete pipe installation system, and we are looking at fully automating the system. Currently, it's a semi-automated system with a bit of manual and mechanical works. So let me bring you through the background of this. Uh, in one of our projects, we are using a mechanical system to install reinforced concrete pipes. The pipe diameters ranges from 2.4 meters to 3 meters. So the procedure at the moment is what we have here. Maybe Chipeng, you want to go to the next step, next slide, which explains the steps. The first step is actually to lower down the pipes onto a trench, and it is placed on concrete sleepers. So you can see the sleepers marked on step one. Subsequently, the pipes are actually pushed mechanically. That means we use a chain pulley and manual methods to pull the pipes one inside the next pipe. So that's how the pipes are being laid conventionally, initially when we started the project. So later on, we realized that this is a very manual and laborious process, and then we sort of automated it to a certain extent by using a mechanical and a hydraulic system. So what we have here in this system is a pipe pusher, which actually pulls one pipe into the next pipe. So first step, as usual, is lower down the pipe. Second step is to use a pipe pusher, which is an hydraulic system, which will clamp onto the existing pipe. And step three is to pull this pipe into the previously laid pipe. And this system proceeds from one pipe to the next. So it's, if you can imagine, it's like either a tunneling trolley system or a pipe jacking system, which is automated and pulls the pipe one into the next pipe. But this still involves manual labor, and it's not fully automated. Now we have a few challenges. Sometimes if we push too hard or the force is overexerted, the edges of one or the both pipes can be damaged, and then it would mean that we have to pull it out again and repair the joints, reinstall, or sometimes even discard the pipe and use a new pipe. Second is the operator who actually pushes a button to install the pipe relies on people on the ground to give him the accurate information to push the pipe. So as the pipe is almost 3 meters, he's not able to see the pipe in its entirety from the place where he's standing. And so the next step, next pain point that we're facing is alignment of the pipe itself. Sometimes it's not fully aligned, and when we push, it simply doesn't get inside each other. So to summarize that, what we need the robotic system to do is to look at providing a real-time. Sorry, can I just be on this? Yeah. So we need to actually give a real-time information about the precise information on the position and the diameter of the pipe. So we think that this could be done by using some sensors, and the sensors could give this information to a robot, and then from there we gather the data and analyze that the pipe is aligned. Second is to just automate the operation of the entire mechanical system, which means we don't have to have a manual intervention. Once the pipe is in position, the robot actually pushes the pipe into one pipe into the next. And finally is to just track the entire performance and analyze the data. So the next slide, please. So the expected outcome is it has to work with the current system, which is a mechanical system. And we hope that with this full automated system, it can reduce the total time taken to install the pipe. Currently, we do something like 4 or 5 pipes a day. So we're hoping that at least one more pipe can be done by fully automating, and then obviously reducing the manpower. I think that's all I have for my presentation, and I'm free to take some questions.
Thank you, BJ. Uh, could you share more details regarding how you're semi-automating the system, just to help innovators startup out there to understand how they could potentially introduce additional sensors? What sort
I
of
think
interfacing?
if anybody has a question, because I don't have the slide with me at the moment,
Mhm.
and it's still in the process of being developed. So anybody who's interested can actually reach out to me, and I can share those details.
Okay. Yep. So for that, send an email to BM at padang.co, and we will help direct the question to Mr. BJ. Yep. Yeah. Mr. BJ, could you share more about uh, the projects, the scale of the projects that you're working on uh, in regards to potentially implementing this solution?
Okay, this current project is a Tuas water reclamation plant, and we have at least about 500 such pipes to be installed. That's in the current project. Now, in the same project, we are in phase one, phase two, and phase three, and so on. There are about 9 phases there. So each of those other projects has similar works to be done, perhaps to a smaller extent. But this is a modular system which can actually be replicated, not just for concrete pipes, even for steel pipes. So any pipes which gets into an open trench, we believe that this system can be used for those pipe laying. Anything which is not pipe jacking, which is obviously micro tunneling, but on an open trench, we think this system is applicable.